Okay, thank you so much for letting me be here today. I'm Sam Volchenboum, and I'm here with Danielle Boyce, and we're going to tell you a little bit about the work we're doing in the epilepsy landscape at the University of Chicago. So I just want to show what our team looks like here, because I think it's really important to understand the breadth of folks that we're bringing together. So in addition to myself and Kirk Wyatt, who are both physicians, Danielle came on, who's a parent as well as a data scientist. We have on the lower left here, Doug Nordley, who's a neurologist, as well as Wim van Drogelen, who's a world expert in EEG processing. Mike, I'm not going to go through everyone, but Mike and Caitlin are experts in data standards. Susie's expert in everything governance and HIPAA. And then we have a computer scientist, Sanjay, who knows so much about how to take large data sets and how to use LLMs and AI. It's a wonderful multidisciplinary team that we've brought to work on issues around epilepsy data. And I'm excited to share with you some of the work that we're doing today. For me, as a pediatric oncologist, this has always been the primary motivator. For many pediatric cancers like leukemia, we took a disease that killed 100% of the kids who presented with it in the early 50s to a disease now that's curable almost 100% of the time. It's an incredible success story. And the only reason things changed were because we could share data. People got together and said, everybody in the country needs to be treated the same way, and we're going to share all of our data and how we do this. And that's how we made these progresses. So what we wanted to do was figure out how to do better data sharing across the world for pediatric cancer. And we did this across all these different groups of different types of pediatric cancer. We got together and got an international group together and said, let's share data about this particular disease, and we're going to learn more. And this is what's happening. So over the last 10 years, we developed these groups. We're building all this scientific knowledge. We're publishing papers. We're advancing the science. And so about 2 years ago, when we were approached by Chan Zuckerberg to do this with epilepsy, we thought, sure, that'll be easy. We'll do the same thing. We will just create a little consortium for each disease group, and everybody will come together and we'll all share our data and we'll all write papers and we'll all learn more about the science and better therapy, and it'll go well. Well, it hasn't gone as well as we had hoped. And we think we understand why. And we've made an interesting pivot after talking to many of you to try to figure out how we can best give back to the epilepsy community. So one of the things we realized is that pediatric cancer is really about specific disease types that are pretty siloed. And within each group, we were able to develop a consensus group that would work together. But for the epilepsies, it's groups all over the place, and they're connected in many different ways. The patients are distributed, and it's very difficult to bring together groups to come to any consensus on data sharing. Now, one of the things we're hoping to learn about is how diseases connect between each other. So KCNT1, of course, connects to many other epilepsies. So just because you have the gene doesn't dictate how severe it's going to be. So there's other genes and mutations that might modify how KCNT1 presents. We know that in other diseases like Dravet, KCNT1 isn't the cause, but KCNT1 activity can affect how Dravet presents for these kids. We know for things like temporal lobe epilepsy, KCN1 mutations are found in some. It's unexpected, and we need to figure out why that's the case. And for diseases like Lennox-Gastaut, there's many genetic contributors, and KCNT1 seems to be part of it. So this fits into a paradigm that I think is critically important, that genes are part of molecular pathways. And as we learn more about each gene defect, we're going to learn more about epilepsy as a whole. And there's going to be many diseases that have a shared phenotype, like DEEs. So we think there are strengths in numbers. We think there's great value to bringing together data. But you can't build a commons without understanding the landscape. And this was our real aha moment in understanding that we needed to figure out what was out there all over the world and try to understand how we could bring these groups together better. So what we've done is we've now have this whole team working on this landscape analysis, where we made a seed list of known parent advisory groups, consortia, funders. We then looked and captured content from over 100,000 publicly available web pages. We used an LLM that went out and got information from this capture to help us understand what was in there. And then we extracted genes, diseases, which groups were part of which diseases, and which data sets were available. And then, of course, we have a human in the loop to help us with verification across these diseases. This AI-assisted curation is really going to change how we think about these types of large-scale data. So we took our 250 seed websites, and as I mentioned, we captured content from these publicly available sites. almost 100,000 web pages. And then we looked into the Genes for Epilepsy site to map these genes to different diseases. So this is how it looks in a data flow in red here. We started with the genes and the diseases, and now we're in the process of going through those and figuring out which advocacy groups around the world are advocating for those diseases and those gene defects, what consortia are available, what data sets and platforms are out there that have data or that are platforms to help collect data, and then what are the gold standards for how we can bring data together so that we can build up this larger data set. I'm going to skip ahead a little bit. So this is where KCNT1 fits in. KCNT1, of course, is on our list. We're going to reach out to you to ask you for help in verifying what we've captured. You're going to tell us, hopefully, what we missed. You're going to flag groups and data sets and registries, maybe even places on Facebook or in private spaces that you might help us understand. Could those data become part of our collection if we obviously make sure we adhere to all the privacy regulations? And then tell us what's useful. What do you want from a public map of rare epilepsy data? Finally, this is what we think a dashboard could look like, and we want to make this a publicly available living resource for people to use. So looking at KCNT1, you have the gene, its inheritance pattern, what the phenotype is, what disorders are associated with that gene, the different patient foundations around the world that are advocating, different registry platforms. These are all going to be clickable links where you can go out and you can look at what's available. We want to track what the therapeutic programs are. We want to see what the FDA, what kind of FDA interactions there have been, links to all the social networks, links to the Mendelian database, and then links out to all resources. So that's all I wanted to cover today. I had to go super fast. I'm happy to share these slides, which have some more detail in them. I want to thank Danielle for all of her hard work in helping me with this project, and Kirk Wyatt, who's helping lead this landscape effort. This is our whole team at UChicago, and we're so excited to be part of the community, and we look forward to working together to build this amazing resource. Thank you so much.
Thank you so much, Sam. This is such an amazing initiative. Floor is open for questions.
Hey, Sam, it was great to see you Monday. And just to tag on to what you're talking about, I mean, the story about leukemia was like one of the most powerful stories I thought in, the Emperor's, the Emperor of All Maladies. I mean, it has stuck with me for so long. And I think that, having watched my son go through this and then my brother go through glioblastoma, I think the other data sharing is critical. And clearly that is the only way to make progress. But I think the other part, in speaking to the kind of clinicians, is a willingness to say and address out loud that what we have today is not enough for a disease when the standard of care is really terrible, like it is for glioblastoma or like it is for KCNT1. And it demands an open-mindedness to say, what is the next thing and what else can we add? And I think that another thing in terms of data, in addition to data sharing, I think our community within the epilepsy world just needs to consider is they should really be thinking like, okay, standard of care is terrible. We should be looking for like, what is like a trial focused mentality? The same way we get cancer patients in my reconstruction world where it's like, the first thing is, hey, what's a trial that's best for this tumor biology? Not like, hey, let's put you on standard of care and good luck with this horrible prognosis. So I just think a willing to be a bit of a pioneer, because the oncologists, at all up in the Northeast who kind of came up with that approach, who said single agents not enough, 2 agents aren't enough, 3 agents, what was it, 4 agents plus radiation, that ultimately killed that cancer and it became this completely survivable disease. I mean, I would like to think at some point KCNT1 will be a story like that. Maybe it's not single agent, maybe it's not 2 agents, but I think that there has to be this aggressive willingness to consider like how far can we push this to, when we've got these devastating disorders. So anyway, that's all I wanted to say. I think that we need data and we need that aggressive mentality and an unwillingness to accept what is a catastrophic diagnosis.
So Justin, I think I really appreciate you bringing this up, because it touches on an entire other area we're working on, which is how do we get massive data out of the EHR that's way beyond this sort of, I call swivel chair technology of people cutting and pasting values into data collection forms. And we're talking to groups like ARPA and Department of Energy and groups that have these massive computing platforms to say, if we brought to you 1,000 patients with not their clinical data, but their notes and their radiology and their EEGs and the MRIs, could we apply exactly what you're saying? It's to say, for this kid, with this disorder and this genomics, what is the right treatment for that kid at that time? I think that's where we have to go. We have to get away from this, let's try this drug, let's try that drug. I'm totally with you on this. It's a very exciting time right now.
I have somebody to connect with offline about this who is like really, really big in the AI space who can maybe help bring some computing power to this problem.
Would love it. Thank you,
Okay.
Justin.
Yeah.
Oh, Danielle?
Yeah, I just wanted to say I couldn't agree more, Justin. You know, my son Charlie is 16. He had infantile spasms, still unknown etiology despite all the resources and testing and great physicians, and has daily seizures and very severe intellectual multiple disabilities. And I often say it's like throwing spaghetti at the wall. And it's disheartening for me to hear that, you know, people with known, you know, mutation, like I always kind of had this perception that if you knew your cause, you were a little bit ahead of where we were, you know, but from doing this landscape assessment, not really. Not really. It feels like most people, most families are also just, let's try this. It worked for Dravet. Maybe we should, oh, this seems to work in LGS. Well, you don't really have LGS, but maybe we should try it. And then it doesn't work. And then it start over and no data are really being collected, right? Within the clinical, you know, like the typical way that we do our natural history studies. And so that's what makes, as Sam said, that's what makes me really excited about the work that I'm involved with our ability to capture and unstructured data, you know, information from unstructured data. And I would even argue the interactions between patient and physician during the period of time between the main visits, which are what is usually captured. I think that roller coaster is often reflected in those messages. So there's a lot, as Sam said, like it's there. It's who has the guts, I think, to go after it. And I think, you know, this group is with you, you know, and the other members of the community is the right time and the right, we're tired of this. And we just need to get it done.
Go ahead, Al.
Yeah, I'm glad that, Sam, you pointed out the contrast between success over the years of treating pediatric leukemia and the state of treating pediatric epilepsy right now. I think a major difference, other than the disease heterogeneities, is the lack of a coordinated effort. There is not an ECOG for epilepsy. Eastern, a consortium of people that were treating childhood cancer. That should exist, you would think, but it doesn't exist. It is really, as my colleague Ann Berg would describe, the Wild West of treating these diseases. There's not a coordinated effort. I think that's one thing that maybe, unfortunately, each of these rare disorders, including KCNT1, has siloed themselves away from everybody else. And I think at some point there needs to be a more collective effort to say, this is your gene, this is the protocol, and everyone has to buy into that. And that's where I think we're missing is a coordinated effort.
So when we first discussed this with Chan Zuckerberg, that was my vision too, Al, was that we would create a national consortium for epilepsy treatment that would have protocols that were described and that everybody would put their data into a common repository. It seemed to me, we found out over the last 2 years, and you guys have much more insight into this than I do, that the community wasn't quite ready to, since the community is already doing data sharing in many different pockets all over the country, it was difficult to get people to buy on to sort of a single kind of data sharing mechanism. One of the things Danielle and I have discussed is, should we be trying to advocate for a national registry, a seizure registry, that every child in the country who has seizures gets on this registry and we start to centralize the data? And out of that, could we develop centralized protocols for taking care of these kids? I think there's many ways to do it, but we need the community to come together in this way.
Yeah, I think infantile spasms, for example, would be a great place to start because so many, not all, but many of the kids start out with IS or IS adjacent neonatal seizures and things like that before you know your cause. And so it would be a great central place to then refer out as part of these resources that we've pulled together. So then it comes with a package for everyone in the stakeholder community around that child and family, as a way to kind of have like that instant referral process. And then with the ability to, refer EHR data, to automatically patient caregiver directed EHR data, that would be an open way of doing that. And it wouldn't interfere with any other studies and it wouldn't be a huge burden on the community, the patient, et cetera, to do it that way. And that would also link and tie the patient at that early stage to all the other initiatives. Because oftentimes we try to put the toothpaste back in the tube and relink the different studies, but this would be a nice way to originate that, and it wouldn't take away from these other efforts like you're doing. So those are things that kind of give me hope that maybe we could pull things together without having to ask the community to stop doing what they're doing so well, and with the knowledge and expertise that they have specific to their phenotype. So we don't want to take over, we just want to coordinate.